Alrighty, so, like I said, a lot of this is terminology or vocabulary. Today's 17th, I just asked myself that and I still don't remember. Alrighty, so, but it's important because we're going to use it all year long. Alright, so, everybody, my grade cards are absent here. Alright. So, talking about this graph here, okay, this is y equals f of x. The first thing we're going to look at is the y-intercept. So, she's no longer with us. Alex, what is the y-intercept? What's the definition of the y-intercept? Or the y-axis? Absolutely. It's the point of intersection. And it is definitely that point there, which gives us 0, 2. Absolutely perfect answer. All right, then, and Joe's absent. Braden, what's the definition of the x-intercept? Yeah, it's just exactly the, instead of the y-axis, it's the point of intersection of the x-axis, exactly. Which on this particular graph is going to give me what points? Say that again?
-6.
All right, I'll take that one. Actually, no, it's -6, 4. It's going to be -6, 0. Because you're going to do it as an ordered pair. I agree with you, it's 4, but it's going to be 4 and 0. Awesome. Okay, now go back in your memory banks to all the different math stuff, especially Algebra 1. And do you remember what there are other vocabulary words that were called, that you use for x-intercepts? When I ask you to solve for x, what are you basically giving as an answer? A solution? Yeah, you're making it harder than it is. It's just a solution. If you're asking for a solution, it's just your x-intercept, okay? The other one is your roots. And the last one, and the one we will definitely use the most, are the zeros. Remember when you were doing your quadratics and you were solving, we factored and then you actually solved to find what x was equal to? You were finding the x-intercept. You were finding the zeros. Okay? All right, so we read a graph from left to right. Okay, just, so you start on that side and read left to right. When it's going up, okay, and it looks like that, okay, and it's going from left to right, then what do you think it's said to be? What do you think, what word would we just use to describe it? If it's going up, what's happening? It's increasing, that's it. Is said to be increasing. Okay, so we have from this point to this point, we have the interval that's increasing, right? So it's increasing from 1, 2, 3, 4, 5, 6, 7, -8 to 1, 2, 3, 4 to -4. Does that make sense, everybody? Do I have any other sections where it's increasing? Where? Two.
Two.
Yep. from -1 to 2. Does everybody see that? Do I have any other sections that are increasing? Where?
5 and 6.
Yep, from here to here, and that's from 5 to 6. Perfecto. Now, what are the other sections of the graph that we haven't talked about or described yet? Ones that are going what? Down. And so if the graph's going down from left to right, what do you think it's said to be doing? Decreasing. Okay, so we can look at the graph 1, 2, 3, 4. So from -4, but I can also look at where it's increasing and know that every time it's changing, that's where it's going to be decreasing. So my next interval is going to be from where? That it's decreasing. What do you have? 2 to 5. Perfect. All right. What is the absolute maximum and minimum on a graph? What do you think absolute maximum, what is that? Absolutely. Oops, sorry, my bad. It's the highest point on the graph. All right, Alex, or Alexis, I'm sorry. What's my absolute maximum point? Which one? Oh, okay, I'm sorry. This is the point, right? You give it as an ordered pair, so it would be 2, 8. Yes, you're correct, but all right, then Anisha's absent. Matthew, what's the absolute minimum going to be? If the absolute maximum is the highest point, what's the absolute minimum going to be? Yep. Because it's going to be the lowest point on the graph. Okay. All right, now the next thing is about our relative maximums and relative well, actually, let me, because when we use that -4, it can be endpoints of a graph. Okay, so that's the actual endpoint. Oops, that's the actual endpoint, and that's allowed for your absolutes. What are relative maximums and minimums? Anybody know? Minions. You know what I meant.
Since this one is like hurting this one's that like is the points that are like highest but it's not maximum.
Yes, very, very close. Okay, very, very close. So it is your maximums you can think of as the peaks. Okay, where it's changing from, so it's basically changing from increasing to decreasing. Okay, and the minimums you can think of as your valleys, it goes from decreasing to increasing. And the big thing about these are, it's a highest or lowest point in comparison to the points beside it. Okay, so basically, when I look at, let's look at the maximums first, okay? I have this point and I have this point, right? Is this point higher than the 2 points beside it? Yeah. So that makes us, what was that one? 1, 2, 3. So one of them is -4, 5, 6. Okay. And on the second one, 1, 2, and 8, are the points beside it lower? No. Or I mean, yes, they're lower, they're not higher. So that one can be a relative maximum. Okay? Relatives and absolutes can be the same point. Okay? Now, let's look at our minimums. We've got this point right here. Are the points on both sides of it bigger than it? Yep, so that one's good. 1, 2, 3, 4. So 5, -2. All right, now we took a look at this one. Are the points on both sides over here and here bigger than that? Yes, so that's going to give us 1. So that's going to be -1, 1. And we have one more point to look at. What about right here? Is the point on this side bigger? Yes. Do we have a point on the other side that's bigger? I don't have a point over here. The graph actually ends. So that means it can't be a minimum, and relatives can't, here I'm scratching this out, relatives can't be endpoints. Okay, good so far? Does that make sense? Alrighty then. So, domain. Dawson, look at this graph. What's my domain going to be? From what point to what point?
Would be -8 with positive
Positive what?
0 or 8
I like the -8 because it's going to go from here, but I want to look at my x value. 2, 3, 4, 5, 6.
That was 6.
Yeah, that's great. And the points are included. So I would have a -8, 6. Good?
You could probably create
Somebody answer that for me. How do you tell if it's included or not included? If the dot's open, then it's not included, and if the dot is closed, then it is included. Perfect. All right, Jude, what's my range? Yep, I like that one. So -4 to 8, perfect. Feeling okay with these vocab so far? Yes? Awesome. All right, let's do example 2 on the back then. We're going to save 3 for tomorrow. All right, Miss Emma. tell me what one of the relative minimums are. Give me as the ordered pair. Yep, like it. -3, 0 is 1. Braxton, do I have another one? Do you have another relative minimum, a lowest points?
The next lowest point?
Yeah. Or just what's the lowest point on the graph?
3 down 2.
Yep.
Down
Okay, so 1, 2, 3, 1, 2, 3. Perfect. So that's going to be 3, -3. I like it.
Down 3, down 2.
Yeah, I knew what you were talking about. I like it. That works. All right. How about relative maximum? Do I have one of those, Miss Tony? I'm looking for hers. Yeah. What was it? I like that. Right here. That's my relative maximum. Perfect. Okay. Do I have an absolute minimum? Selena.
Oh, Miss Myers, stop.
Truly came up. What's your absolute minimum?
But we already answered both of them.
But that's the relative minimum. Now I'm asking for the absolute minimum. What's the difference? So let's clear this up. What's the difference between the absolute minimum and a relative minimum?
The relative minimum is just a minimum of the graph as well.
Absolute is the absolute lowest point. A relative has to do with the points on either side. Yes?
3, -3.
And so 3, -3, because it is our absolute lowest. That's the perfect answer. Awesome. All right, Ben, do I have an absolute maximum?
Yes.
What's that one?
0 and 3.
Perfect. Okay. Now, for my intervals with increase. All right. Mackenzie, can you tell me one of the intervals of increase?
Would it be -3 to 0?
It would absolutely be -3 to 0. I love that. And then Keegan, can you tell me the seconds?
It would be
How about just +3 to 5? Because we're going to go with we're doing X values. Yep, perfect. All right. Heaven, how about an interval of decrease? Decrease. Whichever one you want. You show it in terms of X.
So 0.
2. 1, 2, 3. Yep. Okay. Perfect. And AJ, we've got one more interval of decrease. Right here. So what's my interval going to be? Ryan, want to help him out? Interval of decrease.
-5, -3.
Let's see, 1, 2, 3, 4, 5, 1, 2, 3. Yep, I'm good with that one. All right, how you feeling about these so far? Awesome. Okay, here's what I want to do. I've got to practice on your own. I'm going to give you just, a couple minutes. I want you to do them. We're going to do those tomorrow.
Okay. So,
Yep. And then don't ask your neighbor. Because I want you to, we'll compare them in minutes. Yep, give me 1 second. Okay. Is this good? Okay, you'll have to take yours to go place on it. If you feel comfortable doing it. Plus a little bit more that we're gonna be doing tomorrow with Infinity, but yeah. Say that one more time? Yep, that's exactly what you want to do. That is perfect.